Question 8 on statistics. We're dealing with a common maths exam. Always normally distributed. Mean 176. Standard deviation 36. The mean is 176 and the standard deviation is 36. We're told that the top 10% of students will go forward for a county maths competition. So these guys are in here. There's going to be 10% in here for the top 90. This is my average in the middle, 176. So we need to go to our z-score table and get a value that represents 0.90. That's this point here. So let's see the z-score table. Here's the bit that we need, 90%, 8997 is as close as we can get to it. And we can take the closest one at leave insert. We could be a tiny bit more accurate and look at the difference between these two. 97 to 15, there's 18 in the difference, and we could jump 3 to get exactly to 90, but we don't need to for leave insert. We can just take the nearest value, it's 1.28. So this score here, the z-score here, is 1.28. So whatever x is, we take away our average and divide by our standard deviation. This is the formula that will get us what x is. So x is going to be 36 by 1.28, and we'd have to bring across the 176, giving us an x value here of 222.08. Now read these questions carefully. 222.08. That's the exact value, but these are in integer values, and we're looking for the minimum mark. So they get 22.08. It's not an integer value, so the minimum integer value, 222, will be 2 less. So it would have to be 223 here. Part 2, the school awarded a certificate of merit to any student who scored between 165 and 210. So let's look at where that is. We have 176 in the middle, 165 and 210. So we're looking for this bit in here. So what I would do here, I just get the two tails and add them together, take it away from 1. So let's test 210 against 176 as the average. 36 is the standard deviation. That will give me 1 z-score. And if we test 165 against 176, now you can see the difference here is 11. We could reverse them around and just look at the positive side, because that's all the standard deviation or the z-score table gives us, this side of the curve. So divide that by 36 will give me a second z-score. So this is 0.944 and this one is 0.31. Now to our racket 3055. So we look at 0.31 and we look at 0.94. Now there is a difference between that. Rounding off, we'll have a look maybe and see what the difference is if we round off. So 2 decimal places, let's look at 0.04 and 0.31, and then we'll come back maybe and look at the exact answer if we don't round off and see is there much of a difference. So let's look at the z-score table for these two values. So 0.94 is 8264, so that's what will be in the right hand tail. 0.8264, 1 minus this is in one of the tails. Now what about if this was 100% accurate? 0.944 is 40% of the way. This 4 here is 40% of the way to the next number. And the difference between 64 and 89 is 25. 25 by 0.4 is 10. So the exact answer here will be 10 on top of 8264, which will be 8274. So we'll have a look at that as well and see what we get and what the difference is. So let's have a look at the negative tail, the one on the left with the minus number. So I just wrote this as a plus here. You could see this would be a minus. It doesn't make a difference to the sum. So let's look at 0.31, and actually 3055 will be halfway to the next number. So 0.31, we rounded off to first, 6217. 1 minus 0.6217. Let's see what that gives us. And if we were accurate, 0.30 is at 6179. From 79 to 17, that's 21 and 17, that's a jump of 38. So halfway will be a jump of 19. So 79 at 20, 99, we're going to get to 98. So 6198. 6198 is exact. 6198. So let's have a look at the difference between the two. So 1 minus 0.8264 is going to be 1736. 0.1736, the first value we're looking for. That was what we said was going to be in this tail up here. 0.1736 from a score of 210. And down this end with a score of 165, this tail is going to be 1 minus 6217 is going to be 3783. 3783. So 3783 is going to be this guy. And if we add those two together, we're going to get 9155. So that's the two tails. So the bit in the middle, 1 minus 0.5519. That's not the only way to do this question. I just like identifying it this way. That's going to leave 4481. And we're asked for find a percentage of first years who received the certificate of merit. So that's 44.81% of first years getting their certificate. What if we take the exact values? Could the SEC create a marking scheme where it's actually the exact values? This will be 1726. So this one over here, what did we say? It was 0. What we said 6198 not equals 1 minus, which will be 623802. And if we have 3802 and 1726, we're gonna get 5528, which would leave 44.72% over here. So a slight difference here. 44.72% for me. This is the correct answer. This one over here, will they get full marks for this? I wonder. Let's see in August. Part B. A news report claimed that 6-year students in Ireland studied an average of 21 hours per week outside of class time. Write down what they give you. Average. A leaving class surveyed 60 students, so we have a sample of 60. Chosen at random from different schools. I found the average study time was 19.8 hours, so that's my test statistic, 19.8. And standard deviation, 5.2. So just even by writing down the variables here, it should make you think about how we get our Z-score. So just filling in, we're testing 19.8 against 21. We're going to get a negative answer divided by standard deviation over the square root of n. So this is going to give me, the answer here is minus 1.787. We'll round it off to 7.9 in this case. So let's look at, well, that's what we're asked for, the Z-score. That is the Z-score. Part 2. Find the p-value of this test statistics. So the p-value, and it says comment on what can be concluded from its value in a two-tailed hypothesis test. So the p-value is the two tails. So let's have a look at the two tails here. So my average in here, my tail, we're in the negative here, and minus 1.79. So let's look up 1.79. We get the two tails. So 1.79 is the last one, 9633. So 0.9633. So 1 minus that is going to give me 0.0367. So the p-value is 2 times 0.0367, which is going to give me 0.0734. So we're asked to comment as well, and comment at this hypothesis test with a 5% level of significance. So let me just do a new sketch here. So just a quick diagram here with our two-tailed test. So the two tails add up to just under 7%. So the middle section is 92.66%. So what we can conclude with 95% confidence level, or you could write at 5% level of significance, that students study on average 21 hours per week. You could add to this and saying if this middle section is greater than 95%, we can reject the null hypothesis if you wanted to bring in your null hypothesis and your alternate hypothesis into some part of your answer here. So that's the end of that part. Part C, the school caretaker has a box with 23 keys in it. 12 are for general classroom, 12 for general classroom, 6 for science, 6S, and 5 for offices. Could be colours, but we're just given rooms this time. 4 keys are drawn at random from the box. What is the probability that the 4th key drawn is the first office key drawn? Okay, so we don't know what's what in the first 3. Let's have a look here. Can't be office, can't be office, can't be office, is office. So the probability of this not being an office has to be these 2. So we have 18 choices out of a possibility of 23. Now, I'm going to assume that the key is not put back in. So then we would have 17 left to choose from. We'd only have 22 left in the box. Then we'd have 16 left to choose from. We'd only have 21 left in the box. And then this one has to be an office one. So there's 5 office to choose from out of the final 20 that are left in the box. Now, if they were replaced, it would obviously be 18 over 23 by the same probability again. And obviously the same probability again. But I'm assuming that they want the key not replaced here, 5 over 20. If I got to an exam and I wasn't sure, I'd write both answers down and I'd write key replaced to leave the examiner with no option but to correct both of them. And on this side, key not replaced. I'm sure this confused people when you got to the second part and it mentioned replacement. That's why I'm doing it here. So the answer to the first one is correct to 4 decimals, 0.11518, 0.11518, so 1152. And if it is replaced, and this one works out to be 0.11983, so just 1198. So there is a difference, just be careful. So it says then all the keys are returned to the box. Now, if all the keys are returned to the box, surely it means that they weren't replaced, and then this is what they were looking for. But not explicitly said, but I think with all the keys returned to the box, that's what they were looking for. Then 3 keys are drawn at random from the box, one after another without replacement. So that would have confused people, I think. So what is the probability that one of them is for GC, one for science, and one for office? Okay, well, if the first one out is GC, we just call that G. So we have GSO, that's one possibility. The probability of that would be, for G, will be 12 over 23. Without replacement, the probability for S would then be there's 6 of them, there's only 22 left. And the probability for O, there's 5 of them, and there's only 21 left. If we look at a different order here, we should see a pattern. What if it was G followed by O followed by S? And you should see this pattern after this one. It'd be 12 over 23. By office next, 5 over 22. And you can see here the only thing that changes, 6 over 21, is the order of the top. So all you need to know here is how many different outcomes are there Well, there's 6 different outcomes when we're placing 3 things in order A, B, C, A, C, B. We'll have each letter in the first position twice and each letter in the second position twice, and so on. So there's 6 combinations here, and we said that it was 12 over 23 by 5, or 6, let's say 6 over 22 by 5 over 21. And if you type this into a calculator, you get 0.20327, which is why they're looking for 4 decimals because of the 7 here. A lot of rounding off in this exam. 0.2033.